Hello students, welcome to the session. So here today we are going to discuss about some of the questions which were already there in JEE Advanced 2025. So here some of the questions are there, so let us discuss those questions and see the first question. The question is basically it is from coordination compounds, alright. So what exactly he is asking here is the correct order of wavelength maxima. What he is asking? Wavelength maxima. Wavelength maxima, as we know that this question is from CFT, crystal field theory, right. So he is asking wavelength, maximum wavelength out of all these things, out of the complexes, he is asking us to write in increasing order, right. So as we know that in CFT, d orbital splits into T2g and EG orbital, right. So now what happened when electron is here? See, if it is a strong if we are using in the complex, if there is strong field ligands are present, then what will happen? The splitting will be more. So if strong field ligand is there, then splitting will be more. When splitting is more, automatically what happen? The energy gap will be more and delta E will be, energy will be maximum. Energy will be maximum and lambda will be minimum. But in the question what is asking? Wavelength maximum. So wavelength maximum means what exactly we have to see here? That energy gap, that means splitting should be less. So when splitting should be less means we have to use weak field ligand. So when there is a weak field ligand, what will happen? The energy gap between this will be reduced. So then lambda will be maximum. So out of that, if you can check, we have cyanide, one ligand, the other one is ammonia and the other one is water and the next one is Cl. As we know that strong field ligand and weak field ligand, if you write in increasing order or decreasing order, like see, this is the strong field ligand, comparatively the strong whatever the ligands, if you take the ligands, Cn is the strongest ligand, so splitting will be more, so then energy maximum and lambda minimum. But what is asked in the question? In reverse manner. So that is the reason what we have to check first, weak field ligand. So out of all these things, Cl is the weak field ligand, so it will have maximum wavelength, and anyway option is only it is matching with the A, so the answer is A. Answer is A. Done? Right. Chalo. Next we'll see next question. Right. So the next question is, it is from what? As we know, by seeing the question we can say that it is from chemical bonding, and mostly it is from what? Which topic? Molecular orbital theory, as we know that, which is very important concept, and every time we can expect a question from the molecular orbital theory. Alright, see, let us read the question. Regarding the molecular orbital MO energy level for homonuclear diatomic molecules, what is asking? Incorrect statement. What is asking? Incorrect statement. Now look at here, so we'll check it out. What are the incorrect statements are here? The first one is what? Bond order of Ne2 is 0. So we will check it out. Ne2, so number of electrons are how many here? As we know that it is 20 electrons. When 20 electrons are there, how we will write? Sigma 1s star, sigma 2s star, and we have 2pz, pi 2px, pi 2py, and pi star 2px, pi star 2py, and sigma star 2pz. So now how many electrons we have? 20 electrons, right? So if you fill the electrons according to that, 2 and all the 2 electrons if you fill, so what exactly happens? We'll see whether bond order is same or not. What is the bond order formula? As we know that bond order is nothing but what? Number of electrons, bonding molecular orbital electron minus anti-bonding molecular orbital electron by 2, right? So here how many? Or simply we can cancel out each other. These two will be cancelled, these two will be cancelled, and here we have 6 bonding molecular orbital and 6 anti-bonding molecular orbital. So bond order will be 0. Yes, this statement is correct, but what exactly is asking? Incorrect statement. So this is not answer. Next, what is the next one? The highest occupied molecular orbital, that is HOMO. Alright, for F2 is sigma type he is saying. So we will check it out. So here fluorine, as we know that 9, so total 18 electrons are present. So the same way, the same thing we will use, and here if you write again, what will be there? These 2 electrons will not be there. If you take for 18 electrons, those 2 electrons will not be there, so this is for 18 electrons. If you talk about 18 electrons, then what will happen? Finally, last electrons are present in what? Pi orbitals, it is not sigma orbital. So So as he said sigma, it is wrong, but according to incorrect, this will be the right answer. And next, O2 plus, if you take O2 plus, what will be the bond order? As we know that there will be a small trick every time that we will use in the class, like whenever there is a 14 electrons are there, the bond order will be 3, and if it is 15 electrons, what will be the bond order? 2.5, right? Here what are the electrons that we have? And 16 electrons, it is 2, bond order will be the 2. O2 plus, so it is 15 electrons and O2 is 16 electrons, so its bond order is 2, and here the bond order is 2.5, right? But what is asking? Bond energy. As we know that as what is meant by bond order? We can say number of bonds between it. So when bonds are increasing, automatically what happen? Bond strength will be increased. But what he has given, O2 2 plus is smaller than O2. O2 plus is smaller than O2. It is wrong because O2 plus bond order is how much? 2.5. Its bond order is how much? 2. So obviously it should have greater comparatively oxygen. So what happened here? Bond energy of O2 plus is smaller than bond energy of O2. So this is also wrong statement, but as is asking incorrect, so this will be the correct answer. Next, bond length of Li2 and B2. If you calculate bond orders, both will be 1, but as we know that covalent radius, if you take, what will happen? Left to right, size will be decreased. That is the reason Li2 should have larger bond length comparatively B2. So how it will related to MOT? Because according to MOT, we are calculating bond order between them, and if you calculate bond order, both the bond orders will be same. So when both the bond orders same, now what we are looking? Its covalent radii we are checking. As we know that left to right size is decreasing, that is the reason lithium will have more bond length actually, right? So this statement is correct, but what is asked is incorrect, right? So answer is BC. So we will discuss the next question, that is in the paper 1. The major product obtained from the reaction list 2 are the reactants named reaction mentioned in list 1. So what we have to do here? So we have to write the major products, whatever we are getting here, whatever the major product is here, that should be the reactant of list 1. That should be the reactant of list 1, right? So first of all we have to check that. So first we need to find out the major products, what exactly we are getting here. Once we get the result, or whatever the product we are getting, that we need to match with the list 1, right? So this is toluene. As we know that toluene, whenever it reacts with what? Chromyl chloride, that reaction name is Ettard reaction. Okay, so Ettard reaction. So after that, what is the end product that we will get here? Benzaldehyde. So this is the benzaldehyde. This is the major product that we will get from the first one. And the second one is what? Benzoic acid. When benzoic acid reacts with benzoic acid, it reacts with PCl5, we will get acid chloride, which on reaction with NH3, we will get amide, and as we know that P4O10, right? P4O10 and heat, this which will remove the water, right? So dehydrating agent. So if you can remove the water, then what will happen? We will get C triple bond N, cyanobenzene, right? Next, nitrobenzene. What is the product that we will get? Nitrobenzene. This many times we have seen in our mains papers also. It's very simple question. Nitrobenzene, NO2, metal in presence of acid, which is acting as a reducing agent. So NO2, if it is reduced, what will happen? It will be converted into amine. So it will become aniline. It becomes aniline, right? Aniline, which on reacts with NaNO2. So which is a diazotization reaction. So after diazotization, what we will get? Benzene diazochloride, benzene diazonium chloride we will get, and from the benzene diazonium chloride, if you add water, simply it will be converted into what? Phenol. Simply we will convert into, it will be converted into no. So right. So benzene diazonium chloride, that will be fine, I think. That's it. It's not H2O. If after that it will react, it will become N2Cl. Now N2Cl will be useful for what? Sandmeyer reaction. Anyway, it is there. Next, toluene. Next one is toluene. Toluene, when it reacts with Cl2, what will happen? It reacts on what? As he has given H nu. So in presence of sunlight, it will react with alkyl group. So it converts into what? Anyway, Tollens reagent has to react with it. So Tollens reacts as it is a mild oxidizing agent. So here it might be converted into what? CHCl2, right? When it reacts with Tollens reagent, now what will happen? Before to that only hydrolysis is there. So it will become aldehyde, benzaldehyde, which on react with Tollens reagent. Which on react with Tollens reagent, it will be converted into COOH, right? And this SO2Cl2 he has given, but if it would be SOCl2, that will be the good option comparatively SO2Cl2, right? So if it reacts with SOCl2, then it will become what? C double bond O Cl, which on reaction with NH3 we will get amide, benzamide. So as we know that amides means definitely it would be Hofmann bromide reaction, right? What is the last one we have here? Aniline. If at all if you take aniline, so this is aniline. Whenever it reacts with acetic anhydride, as we know that acetic anhydride is nothing but what? Which is simply we are protecting it. As we know that it is highly activating group, that is the reason we are protecting it with what? Acetic anhydride. After that, if you go for nitration, what will be the final product we will get? After all those things, we will get final product is para-nitro-aniline we will get. Now we will check it out what exactly will be the answer. So in the first one what we got? Benzaldehyde. Benzaldehyde will be there for what? As we know that it is not in the Stephen reactions. For Stephen reaction we need to have cyanobenzene. For Sandmeyer reaction anyway benzene diazonium chloride is there. For Hofmann bromide we have benzamide, and Cannizzaro reaction benzaldehyde. So for S, for first of all we see P. For P the answer is 2. So out of these two will be the wrong. So out of these two we have to check. And Q is 4 he has given, Q is 3 he has given. Q 4 what exactly we got in the 4? Aniline, and it is benzamide. So it is not answer. So what will be the answer now? This will be the answer, because nitrobenzene can be converted into aniline. Aniline can furtherly it undergo diazotization reaction and it will be converted into benzene diazonium chloride. As we know that Sandmeyer and Getterman reactions that we will get from benzene diazonium chloride. So the answer is B. Right, next. The the complete hydrolysis of ICl, ClF3, BrFi respectively. So this question if you see, these all are interhalogen compounds. So whenever interhalogen compounds they will undergo what? Hydrolysis. Higher electronegative atom, what will happen? High electronegative atom can be converted into halo acid, and the other atom will be converted into what we can say? Oxy acid, right? So now ICl, if it is undergo hydrolysis, here what is the higher electronegative atom here? Chlorine will have more electronegativity than iodine, so it will be converted into HCl, and plus what exactly we have? HOI, HIO. So if you remove this, it will become IO minus. So we have two options here. We have two options. Next we will see what is the next one. ClF3 has given, ClF3 and H2O. Then what exactly we have to get? We have to get 3HF. See, because higher electronegative atom is fluorine, so we should be converted into halo acid, right? HF. So if you take 2H2, then what is the other one we have here? HClO2, because two oxygens are there. So what is the anion form of it? ClO2 minus. So ClO2 minus is there, and here ClO minus is there. So answer is A. Answer is A. Chalo, we'll go for the next question. Right? Look at here. So he has given what? A sequence of reactions are there, and out of that what we have to find out? First we have to write the compounds. Later we have to find out unsaturated carbon atoms. Unsaturated carbon atoms. The first one, what he has given? Benzene, and we have a carboxylic acid which on reacts with Br2 and red phosphorus. as we know that, which is very famous reaction, that is HVZ reaction, Hell-Hollard-Zelansky reaction. So here what exactly we will get? We will get alpha halo acids we will get. And here what is asking? Number of unsaturated carbons. So if you see sp2 carbon, so what are the, how many carbons we will get? From here 6 and this is 1. So total 7 are there. Next, what is this? Aromatic aldehyde is there and aliphatic aldehyde is there and base is there, right? So whenever base and aldehydes are there, definitely it will go either what we can say aldol condensation or Cannizzaro, and there is another option, Claisen-Smith reaction. As we know that it is aromatic aldehyde as well as this aliphatic aldehyde is there, so it will undergo Claisen-Smith reaction and it will be converted into what? As alpha beta unsaturated aldehyde we need to get. Alright. So if you write, first of all what will happen? Beta hydroxy aldehyde we will get after removal of, say as he has given 293 Kelvin. So if you remove the water you will get alpha beta unsaturated compound, unsaturated aldehyde. So first of all let me write it is in the form of beta hydroxy, and next what will be there? This is CH2 C double bond OH. If you remove the water, what we will get? Cinnamaldehyde we will get. So how many carbons are there? How many sp2 carbons are there? 1, 2 and here, and this is also 3. So total 3 carbons are there and here 6. So total 9 unsaturated carbons are there. 9 unsaturated carbons are there. Right? Chalo, next we will check the third one also. What exactly we have here? Triple bond is there and NaNH2. As we all know very well that this hydrogen specifically when it is attached to sp carbon, which is more acidic, and NaNH2 if you take, as it is a base, it removes that hydrogen. Basically here acid base reaction is happening. So now C minus, it will react on this carbon because it will have a positive charge here as because of electronegative atom. So it will become C triple bond C, CH2, CH double bond CH2. This is the product that we will get, but rest still one more reagent is there, Hg2 plus and H3O plus. This reaction, Khushrov reaction we can say. So here what exactly happens in this? Whenever triple bonds are there, this triple bond can be converted into what? I'll write here. This can be converted into C double bond O, right? CH and CH2, CH double bond CH2, 1, 2, 3 and here anyway double bond is there. So total how many will be happen? Total 1, 2, 3, 4 and 10. So highest will be 9. Here double bond will not be there. So 1, 2, 3 and these are 6, 9. So total 9 compounds are, 9 sp2 carbons are there. So 9 and 9 is matching 7. So we have one more option that we have to check. So here what happened? As we know that everyone knows that O3 and ZnH2O. What is this? Reductive ozonolysis. When reductive ozonolysis is there, then what happened? The bond will broken here. So if it breaks here, what is the product that we will get? This will become ketone and this is anyway aldehyde. After that 2 equivalents of methyl magnesium bromide. As we know that methyl magnesium bromide RMGX, here it is acting as nucleophile. Nucleophilic addition reaction will happen. It comes here and here also the same way it happens, and we will get what? 2 alcohols we will get, and this is OH, and here also we will get OH. After that if you remove H plus and heat it, then what will happen? There will be a removal of water, and if you remove the water, what will be the product we will get? Now check how many atoms are there. 1, 2, 3, 4 and these are the 6. So 6 plus 4. So total how many are there? 10. So here 9. So here we got how many? 7. Here we got 9. Here also we got how many? 3 plus 6, 9, and here 10. So according to the question, highest number of unsaturated carbon atoms. So what is the answer now? S. S is the answer. Right? Next, this is also very simple question. Right? So what is asking? Number of pH bonds. Is asking us to find out number of pH bonds. So simply we have to write pH bonds. So if you write the structure of this is phosphoric acid. So phosphoric acid, if you write the structure H3PO4, as we know that we need to have a clarity that phosphorus will not extend its covalency more than 5. So make sure that it should have only 5 bonds. So as we know that every time we will write P double bond O, and still how many are there? OH, OH, and rest all hydrogen and oxygens we will write in the form of OH. And next H3PO3, this is phosphorus acid, right? So it will become what? P double bond O. Still how many are there? OH, OH, and one hydrogen bond is there, right? Here one pH bond is there. Next H4P2O7. This can be called as what? Pyrophosphoric acid. So if you write P and P, you will write like this whenever we have a two compounds. So first make sure of you just write P double bond O, and then anyway one odd oxygen is there, so we will bridge it. So OH, OH, 1 2 3 4 5, done. So check it out, all 7 oxygens are there, right? 1 2 3 4 5 6 7, right? Done. Next, what is the other one? Hypophosphoric acid. So if you see hypophosphorus acid, if you take this P double bond O, and what exactly we have? OH, and only hydrogens are there that we can directly attach to the P. So here what are the compounds like in this which we will have a pH bonds? Option B as well as option D, right? That's all, right? Next, from here our HOD will discuss all other questions, right? Thank you.
Hello students, let us continue the questions which are left. So the paper, we had some selective questions only. So the question is in this now gaseous state, which is there only for our IIT advance. So the question is molar volume of van der Waals gas calculated by expressing van der Waals equation. So as it is given for molar volume, so we consider van der Waals equation for 1 mole of gas, that is P plus A into N square. N will become, when you have 1, V square into V minus NB, that is again 1, is equal to RT. So we have to express this, that is already what we study in the Boyle's temperature application, where we are converting the equation into V cube terms, or even we use the critical volume applications, we do that. So let us expand the equation first. PV minus PV minus A by V, sorry, plus A by V minus AB is equal to RT. Now let us bring the PV term only V cube terms, no? So let us consider this, multiply with V square, let us divide with P. So that multiplying with V square on both sides, dividing with P, therefore it will become V cube minus, this is P cancels, B into V square, plus this will become A V by P minus AB into V square by P. This also you bring it right left side, therefore it is minus RT into V square by P is equal to 0. Bring the V square terms to one side, that is V cube minus, this is B, this is plus AB by P, where it is 3 terms v square by p. This is somewhere we multiplied, sorry, this is ab by v square. So this v square term will be cancelled. So this is not there as v square term. This is now RT by P into V square. This part will be plus A by P into V. This is anyhow like a normal constant, AB by P is equal to 0. So he said consider the coefficient of V cube, V square, and the coefficient of V, that is minus P plus RT by P by, this is the V square coefficient, this is A by P. So he gave AB values, he gave the pressure, then substituting that, temperature is also there, directly we get the answer. So we are not solving this, just take the procedure. Next, considering the ideal gas behavior, the expansion of work done in 144 grams of water electrolyzed. So water on electrolysis, as we know, water on electrolysis gives hydrogen and oxygen, and the process is done at constant pressure. Therefore, at constant pressure and temperature it is done, because at 300 Kelvin. So the process is isothermal as well as isobaric, but it is isothermal at external pressure is constant, the process will become irreversible process. So for an irreversible process, again work done is nothing but equal to minus P external into delta V. But instead of doing that P delta V, you can write it as minus delta NG/RT, because as per the ideal gas equation PV is equal to nRT. Delta PV, P delta V is nothing but delta NG/RT in this case, because temperature is same. So what is this? Is anyhow water liquid, this is hydrogen which is gas, or oxygen which is also gas. So delta Ng for the process is, this is only gaseous products exist, so the gaseous products only what we take. Therefore this is minus, this is 144 grams of water. So the number of moles of water what we considered is 144 by 18. So that how many moles of this will exist? 144 by 18 only, because 2 moles of this will give 2 moles. This is 144 by 18 by 2, half mole. So the delta Ng will be sum of these two. So you can substitute that. There is anyhow R value what we can directly substitute. You can calculate in terms of joules or whatever it is. Then next it is temperature. Temperature is also mentioned, R value is also mentioned, what you need to consider. So substituting that you will again get. So delta Ng is what we are actually taking from these two. So let us do the calculations thing. Now let us see this. There is set of reactions, a sequence of reactions are there. From this, what is you are getting the yield of the product as 50%, 50% here. Here you are getting 100%. So the first reaction is aryl halide, which is actually even existing in the form of, this is acetal, sodium with dry ether. Reaction is now aryl halides with sodium in ether is Fittig reaction, and hydrolyzed later. So the reaction is acetal will be anyhow hydrolyzed, will convert into aldehyde later, but we are protecting that aldehyde in the reaction, so that aryl halides will react to form. So this is anyhow converted to aldehyde, what we actually see in this acetal part. Aryl halides are reacting, will convert into, let us write because the space is there, not there here. So this is what we get as aldehyde will exist as now and this aryl halide what is reacting with another molecule. So phenyl groups with two aldehydes in it. So this is our P. So he said it is 100%. So the reaction is started with, actually he said 16 moles of X. So if you are taking 16 moles of this, with 100% you will get, because as it is Wood's Fittig type or Fittig reaction, two aryl groups are reacting, 16 moles will give only 8 moles of this. So this will get 8 moles. Now the reaction with sodium alkali in heating then hydrolyzed, the process is nothing but we had aldehyde groups without alpha hydrogen, so the reaction is Cannizzaro reaction. So intramolecular Cannizzaro. So one aldehyde group will convert into acid, other will convert into alcohol, then it is anyhow acidified, but actually acid was existing as salt of that acid. So it is converted to finally acid because it is protonated, acidified, CH2OH. So this is Q. But he said yield of this reaction is only 50%. So for 8 moles you should get 8 moles. But here it is 50%, this is only 4 moles. Now this is next. The reaction of sodium, soda lime and heated. Soda lime heated do the decarboxylation process. So the direct reaction that will convert into benzene and this is like alcohol. So this is our R. He said yield of this process is also 50%. So 4 moles are there, you will get 2 moles. Next, the reaction of PBr3. So alcohol on reaction with PBr3 will be converted to alkyl halides. So it will convert into CH2Br. This is our T. Again he said it is again 50%. So 2 moles should give 2 moles. Now we will get only 1 mole. Then the reaction of this with sodium hydride, that is hydride donor reagent, alkyl halides will convert into generally alkanes only. So it will convert into directly that CH3. This is our S. So the reaction is again only 50%. So this is again you will get only half mole. R is also used. Okay. So the next. So the process is, what is the question is, now the total amount of product S. So you have to see the molecular weight of this. For this molecular weight, half mole is there. What is the mass in terms of grams? Okay. A simple one. The next. This is the another one directly from inorganic. Qualitative analysis, the direct question. It's the group reagent simply. Suppose you consider the reagents, whatever is given in the list 1. H2S is passed in presence of ammonium hydroxide. We say it is a group 4 reagent. Ammonium carbonate is added in presence of ammonium hydroxide alkali condition. It is group 5 reagent. Ammonium hydroxide in presence of ammonium chloride. It's the group 3 reagent for the qualitative analysis, for the cation analysis. H2S is passed in presence of dilute HCl is group 2 reagent. So let us just see the cations which are there in the list 2. This is group 2. Aluminum is group 3. Manganese is group 4. Barium is group 5. Magnesium is group 6. So anyhow you don't have magnesium reagent anywhere. So directly we just match the things. So 4, that is 3. P. Group 4, P is 3. Next. So these two will go. Then group 5 reagent is 4. So this is okay again. Then group 3 is 2. So this is the correct match. Okay. Then next it is from the paper 1 till now. We are having paper 2 already discussed some questions. Paper 2 already discussed. This question is discussed. This was covered. Now coming to this. The reaction with lithium aluminum hydride. So this is an ester. This is an ester with lithium aluminum hydride. Ester converts all aldehydes and all these into alcohols. So the P will be what we get, the reduction of this carbon of carbonyl, so that it will convert into CH2OH. See the number of carbons. This is one carbon. This is the, because here the carbons is very specific for us. This is carbon. This is carbon. This is a chiral carbon already mentioned. This is CH2. This is CH2. So this is now pH. This is CH2, CH2OH. So this is our P with the reaction with lithium aluminum hydride. Then the reaction with chromic oxide and acidic condition. So it's nothing but potassium dichromate or dichromate, which is a strong oxidizing agent, converts both into acids. Primary alcohol will be converted to acids. So our Q will be, this is converted to COOH. This carbon is also converted to COOH. Then we have pH like this. But from this P also we are doing another reaction, that is reaction with H2SO4. So reaction with H2SO4 should give, this is an alcohol, this is an alcohol, will give double bonds. So the reaction will give double bond here. This is pH, here double bond. So this is our S. Dehydration of alcohol. Then this Q, this was Q. This is treated with again soda lime. It's a decarboxylation. So this CO2 is lost, here CO2 is lost. That means this carbon is converted to CH3, this carbon is also converted to CH3. So we have now just CH3, CH3 this side, this is CH3, this is CH3. Then we have pH like this. So this is our R. Let us see the statements now. Rp is optically active. This is CH2, CH2OH. This is CH2, CH2OH. Both the similar groups exist. So P is not optically active. So this statement is wrong. The next one. S will give Bayer's test. So it's nothing but cold dilute alkaline carbon unsaturation test can be given by S. So this is correct statement. Q gives effervescence with sodium bicarbonate. Carboxylic acid will give sodium bicarbonate test. Correct. R is an alkyne. So R is just an alkene, which is also now we can say achiral. So this is also wrong. The next. Solubility of potassium iodide in aqueous solution prepared from the solution mixer. So the barium nitrate, BaNO3 taken twice, plus sodium iodide, NaIO3, should form barium iodide plus NaNO3. So if you balance the equation, this is 2, this will be 2. Now let us see, because he is asking that solution mixer, how many moles of this is taken. So this is 200 into 0.01. That means it is number of millimoles, that is 2 millimoles of barium nitrate. Then number of millimoles of barium iodide, sodium iodide. This is 100 into 0.1. This is 10 millimoles. but as the stoichiometry, 1 mole will react with 2 moles. This 2 millimoles will react with 4 of this, so that we are left out with 6 millimoles of NaIO3. Then we are getting the barium iodate, which will generally precipitate completely because of IO3 minus exists in the solution. Because common ion effect exists, this will precipitate. So whatever is formed, you need not consider, because it is anyhow sparingly soluble. So you need not consider this part, because you are asking only the solubility of this. But the solubility equation of barium iodate is BaIO3 taken twice will be in equilibrium with barium ions and IO3 minus ions. If we consider solubility of this will be S, this is S, this is 2S first. But already IO3 minus exists in the solution. So let us see what is the IO3 minus concentration we get from NaIO3. That is only we just predict the NaIO3 concentration. 6 millimoles will exist in 200 plus 100, that is 300 ml. Therefore it will become 6 by 300 will be the concentration of NaIO3. That is nothing but it is 1 by 5, this is 1 by 50. So that it is 2 into 10 to the power of minus 2. So the concentration of IO3 minus which we are getting from NaIO3 is 2 into 10 to the power of minus 2. But it's sparingly soluble with Ksp value of 10 to the power of minus 9. This 2s value is negligible when compared to this. So the overall concentration of IO3 minus becomes only, it is 2 into 10 to the power of minus 2. So now the solubility product Ksp, that is 1.5 into 10 to the power of minus 9 is equal to barium ion concentration, that is S, IO3 minus concentration whole square, that is 2 into 10 to the power of minus 2 square. So what will be S value? You can try or calculate it. This is given in terms of 10 to the power of minus 6. So you can solve it that. This is it, simply S is 4, this is 1.58 into 10 to the power of minus 9. This is 4 into 10 to the power of minus 4. Solving it. Next. Consider a reaction A plus R gives the product, because we selected some questions only, because the other questions which are just direct questions, that is just left. So the rate of this reaction is measured as K into A into R concentrations. At the start of the reaction, the concentration of R is R naught is 10 times of concentration of A, that is A naught. Reaction can be considered to be the pseudo first order reaction with the assumption that this K prime is K into R concentration as constant. Due to this assumption, the rate error what we are getting in the rate measurement is when the 40% of the reaction is completed. So let us say the reaction is A plus R is giving the products. The given condition was, initially we had, if concentration of A is taken as A naught, concentration of this is taken as R naught, but he said R naught is 10 times to the concentration of this is 10 A naught. When the 40% of the reaction is completed, so let us do the normal condition, let us do the assumption condition, because with the assumption there is an error. So relative error what he is asking with respect to assumption and without assumption now. So first 40% is consumed means 0.4 of A naught will react. In this 0.4 of A naught will react. So this will become 0.6 A naught. This is nothing but 9.6 A naught. So what is your rate initially without an assumption is R is K into concentration of A is left after some time when 40% is completed. 0.6 A naught, this is 9.6 A naught. Then the assumption is where you are replacing this K into R, K into concentration of R as K prime. So that means with assumption, if you assume it, the equation is R is equal to pseudo first order, R is equal to K prime into concentration of A only. because K into R is taken as K prime. But this K prime is nothing but it is R concentration initially taken as 10 times of A naught. So it is directly 10 A naught is the concentration into K. Now what is A naught concentration is just it is again 0.6 of A naught. So the rate when it is assumption is there, when assumption is not there, there are two rates. So you can just see this is nothing but it is K into, this is directly 6 into A naught square, this is with assumption condition, this is without assumption condition. So predict the difference of this, that is nothing but your assumption, percentage of error. Okay. So the next, just do the calculation part that is left out at the last. Then a linear octasaccharide with a molecular mass on complete hydrolysis produces 3 monosaccharide ribose, 2 deoxyribose and glucose. Amount of deoxyribose formed is 58.26% of weight by weight. Total mass of the monosaccharides produced in the hydrolysis. So in the hydrolysis what we had is octasaccharide. The octasaccharide contains 10 glycosidic linkages. So the number of glycosidic linkages will be 7. So when the molecular mass of octasaccharide is 1024, for every hydrolysis the glycosidic linkage is cleaved, 7 glycosidic linkages will be cleaved. Therefore it will be 7 into 18 times of water will be added. So that the overall total hydrolysis products mass will be sum of this. So what is that? You will see 18, 17 times 56, 126. So if you add 126 to this, this will be 10, 5, 1, 150. So your total hydrolysis product mass is 1150. Now, but what he said is 2-oxyribose is 58.26 by weight of this hydrolysis mass. So the 2-deoxyribose is 1150 into 58.26 by 100. This is the mass of it. But molecular masses of all compounds are given. So the number of moles, because he is asking how many units will exist in 1 mole. So the number of moles is the mass by total molecular weight, 58.26 by 100 by molecular weight of this 134. Otherwise you can see the mass only, I think enough. I think the units are not required. For ribose you don't require, no. So then what is your mass totally? What you get is, if you just count it, then you can see the total glucose units and ribose units. The question is the number of ribose units only what we require. Total mass is this, otherwise you can just subtract this mass because we don't require 2-oxyribose moles only. Number of that you don't require. So total mass of the 2-deoxyribose is there. Subtract that from this mass. The left out mass has to be glucose units as well as only the, what is that, the next one, ribose units. Glucose units and ribose units. This is doing this calculation around 60%. 60% means 1150, if you say 60%, 39, then 6, around 690 you are getting. So 690 if you subtract it, this is 0, this will be around 6, this will be 4, around 460 only we are left out. So for 460 if you use the glucose units, if assume the 2 glucose units at least, then it will become 360 because we require ribose units only. So if you assume the 2 glucose units you get, then it will become effectively 360 will cancel, only 100 will be left. then the ribose molecular base is already 150. Therefore, the number of glucose units cannot be, or even you assume the ribose units only we calculate. That's you can't assume that. That's why you are assuming the glucose units. So this is now left out will be only 100, that cannot be your ribose unit mass. So the glucose units should not be more than 1. So that will be subtracted from this. Then you will get the left out mass of the ribose units, that you can divide approximately with this. You will get around, this is, if you just see, it may be around 300 you will get, because we do the approximation that will give 460, otherwise it will be less, it will be little bit more, because we assumed the 60% there. So your total number of ribose units has to be effectively 2. Okay, so this is, I think, the last one. Okay, thank you.